Assalamu alaikum. Midline Properties Part 5. At the end of this video, students will be able to recognize an isosceles trapezoid and its properties, and recognize a right trapezoid. Materials: paper, pencil, ruler, compass, and your textbook edition 2017 or 2012. Parallel lines. How to show that two lines are parallel. What do we mean by parallel? Means that they never meet. First, by alternate or corresponding angles. If we have two alternating interior angles or two corresponding angles which are equal, then the two lines are parallel. 2. If they are opposite sides of a parallelogram. As we know, one of the properties of a parallelogram is that it has opposite sides which are parallel. So, if these two lines are the opposite sides of a parallelogram, then they are parallel. 3. If one of the two lines joins the midpoints of two sides of a triangle and the other is the third side, converse of midline theorem in a triangle. As we learned before, if we have any triangle, if we have the midpoints of two sides of this triangle joined by a segment, then this segment is parallel to the third side. 4. If one of them joins the midpoints of the non-parallel sides of a trapezoid and the other is one of the bases. Converse of midline theorem in a trapezoid. The non-parallel sides of a trapezoid, the midpoints of these non-parallel sides joined by a segment, then this segment is parallel to the bases. Isosceles trapezoid. Definition: if the two non-parallel sides of a trapezoid are congruent, which means they are equal, then it is an isosceles trapezoid. Same as in triangle, if we have a triangle and we have two sides of a triangle that are equal, we call this triangle isosceles triangle. In trapezoid, we have the parallel bases and we have the non-parallel sides. If these non-parallel sides are equal or congruent, then this trapezoid is called an isosceles trapezoid. These are the non-parallel sides. We have AD is parallel to BC and AB is equal to DC. In an isosceles trapezoid, we have three properties. Property 1. In an isosceles trapezoid, each pair of base angles is congruent. Here we have the base angles, angle A and angle D are base angles. Also, angle B and angle C are base angles. The base angles of an isosceles trapezoid are equal. So here we have BAD is equal to ADC and ABC is equal to BCD. Property 2. The diagonals of an isosceles trapezoid are congruent. What do we mean by diagonals? Diagonals are the sides joining A with C and D with B. Here we have AC and DB are diagonals of an isosceles trapezoid. These diagonals are equal in isosceles trapezoid. So AC is equal to BD. Property 3. The axis of symmetry of an isosceles trapezoid is the perpendicular bisector of the bases. The axis of symmetry is the line that cuts the isosceles trapezoid into two identical shapes. The axis of symmetry of an isosceles trapezoid is the perpendicular bisector of the bases. That is, it is perpendicular to the bases and it passes through the midpoint of the bases. We can see these properties on GeoGebra on any isosceles trapezoid. So here we have the isosceles trapezoid A, B, C, D. We have DC is equal to AB, DC is equal to AB. The non-parallel sides of a trapezoid are equal. Then it is an isosceles trapezoid. We have three properties. The first property is that we can change the size of this trapezoid and DC equal to AB always, as we see here. Okay. Now, property 1, in isosceles trapezoid, each pair of base angles is congruent. As we see here, angle D is equal to angle A, and angle C is equal to angle B. If you change the size of the trapezoid, the angles are always equal. Property 2, the diagonals of an isosceles trapezoid are congruent. The diagonals here are AC and DB. These diagonals are equal, as you see here. If we change also here the size of the trapezoid, the diagonals are always equal. Property 3, the axis of symmetry of an isosceles trapezoid is the perpendicular bisector of the bases. If we draw the axis of symmetry, it is the perpendicular bisector of AD and BC, and if we move the trapezoid or change the size of the trapezoid, the axis of symmetry is always the perpendicular bisector of the bases. How to show that a quadrilateral is an isosceles trapezoid? First, show that the quadrilateral is a trapezoid by proving one pair of opposite sides are parallel. How to show that a quadrilateral is a trapezoid? If we just prove one pair of opposite sides are parallel. So here if we prove AD is parallel to BC, then this is a trapezoid. Second, show that it is isosceles. How to show that it is isosceles? We have 3 ways. A, the non-parallel sides are congruent. If we prove that AB is equal to DC, the non-parallel sides, then this trapezoid is isosceles. B, one pair of base angles is congruent. If we show that angle A is equal to angle D, then this trapezoid is isosceles. Or we can show that B is equal to C. C, the diagonals are congruent. If we prove that AC is equal to DB, these diagonals are equal, then we can say that it is an isosceles trapezoid. So, a trapezoid plus non-parallel sides are equal, what do we get? Isosceles trapezoid. Or, a trapezoid plus equal diagonals give us an isosceles trapezoid. Or, a trapezoid plus one pair of base angles is congruent, we get an isosceles trapezoid. So to show that a quadrilateral is an isosceles trapezoid, we have 3 ways. Application. ABC is an isosceles triangle of vertex C. Here we have triangle ABC, isosceles of vertex C, which means that AC is equal to CB. D and E are the midpoints of AC and BC respectively. D is the midpoint of AC and E is the midpoint of BC. We have to show that ABED is an isosceles trapezoid. A, B, E, D, this quadrilateral is an isosceles trapezoid. As we said before, we have 3 ways. The first way, trapezoid plus the non-parallel sides are equal. Second way, trapezoid plus one pair of base angles are equal. Third way, trapezoid plus diagonals are equal. So first, before we prove it isosceles, we have to prove that ABED is a trapezoid. Then we choose one of these ways to show it isosceles. Please pause the video and try to solve this application. Solution. First, how to show that ABED is a trapezoid? To show that a quadrilateral is a trapezoid, we have to show one pair of opposite sides parallel. Here we have, it is clear that DE is parallel to AB. How? By converse of midline theorem in a triangle, since D is the midpoint of AC and E is the midpoint of CB by given, we get that DE is parallel to AB. So DEBA is a trapezoid. In the triangle ABC, D is the midpoint of AC given, E is the midpoint of BC given. Then, using converse of midline theorem, DE is parallel to AB, so, or then ABED is a trapezoid. Now, how to show that this trapezoid is isosceles? We have three ways, but which way is convenient here or it's applicable here? Here we have isosceles triangle ABC given. So we have to use this given. We have to benefit from this given. What is the special properties about an isosceles triangle? It has two equal sides and two equal angles, which are the base angles. Okay, but the base angles of this isosceles triangle are also base angles of this trapezoid. So if A is equal to B, angle CAB is equal to angle CBA, then these base angles of a trapezoid are equal. So now required to prove isosceles. BAC equal to ABC, since ABC is an isosceles triangle at C, therefore ABED is an isosceles trapezoid having two angles at the base equal, or two base angles are equal. Right trapezoid. Definition. A right trapezoid has one of the non-parallel sides perpendicular to the lines holding the bases. What do we mean by perpendicular to the lines holding the bases? This is a right trapezoid. AB and DC are the bases, they are parallel. The lines holding the bases are AD and BC. One of them is perpendicular to the bases, then we have a right trapezoid. AD is perpendicular to the bases AB and DC, then trapezoid ABCD is a right trapezoid. AD is called the height of the trapezoid. This is the height. AB is parallel to DC. AD is perpendicular to AB. Also AD is perpendicular to DC. How to prove that a quadrilateral is a right trapezoid? Before we show that this trapezoid is right or this quadrilateral is a right trapezoid, we have to show that it is a trapezoid by proving one pair of opposite sides are parallel. So we show that the quadrilateral is a trapezoid, and we prove also it has one right angle. One right angle is enough to show that this trapezoid is a right trapezoid. Assignment. Review from the textbook, pages 94 and 95 edition 2012, pages 98 and 99 edition 2017. Homework from the textbook, exercises 15-16, page 98 edition 2012, exercises 15-16, page 102 edition 2017. But pay attention, in exercise 15 in the new edition 2017, there is letter D by mistake. Summary. Midline theorem in a triangle. We have midpoint of the first side, a line passing through this midpoint and parallel to the second side. We get the point of intersection is the midpoint of this side. Converse of midline theorem in a triangle. First midpoint, second midpoint, the line joining these midpoints is parallel to the third side. The line segment joining the midpoints of two sides of a triangle is equal to half the third side. Midline theorem in a trapezoid. We have one midpoint of the non-parallel sides of the trapezoid, a line passing through this midpoint and parallel to the bases. We get the second midpoint. Converse of midline theorem in a trapezoid. We have two midpoints of the non-parallel sides of the trapezoid joined by a segment. This segment will be parallel to the bases. In a trapezoid, the line segment passing through the midpoints of the non-parallel sides is equal to half the measure of the sum of the two bases. Properties of an isosceles trapezoid. Isosceles trapezoid, each pair of angles is equal, diagonals are equal, at the axis of symmetry is the perpendicular bisector of the bases, and the non-parallel sides are equal. A right trapezoid, a trapezoid plus one of the non-parallel sides is perpendicular to the lines holding the bases, we get a right trapezoid. How to show that a quadrilateral is an isosceles trapezoid? First, it is a trapezoid plus non-parallel sides are equal, or equal diagonals, or one pair of base angles is congruent. We get an isosceles trapezoid. Thank you for your attention.